Today we will learn the associative property of various operations performed on rational numbers. Associative properties are related to the use of parentheses in operations. Associative means being together. Here, it means keeping the numbers together means forming their groups. We do this using brackets. To perform proper operations on numbers, we need to know about use of parentheses. That is, understand the associative property. In the previous class, we learned that for performing addition on integers, we can group them in any ways, that is, with the help of parentheses, any two numbers can be kept together. We will get equal results in every situation. So we say that for integers, addition of integers is associative. Like addition, multiplications for integers are also associative, but subtraction and division for integers are not associative. Today, we will talk about associative properties of various operations performed on rational numbers. Let us first talk about the addition of rational numbers. Suppose the amount of water in 3 bottles is 1/6 liter, 2/5 liter, and 2/3 liter respectively. If we want to find the total amount of water, then we have to add these. That is, we have to find the result of 1/6 plus 2/5 plus 2/3. To simplify this, we can create groups like this or like this. If we first make a group of 1/6 and 2/5, then the sum will be 17/30. By adding the number 2/3 to it, we will get the result 37/30. If we make a group of 2/5 and 2/3 and add them, the sum will be 16/15. Adding 1/6 with this, we will get the result 37/30. From both the conditions here, we find the total amount of water in all the bottles is 37/30 liters. Since the results are same in both cases, we can say that the addition of rational numbers can be made by grouping in any way. That is, the addition of rational numbers is associative. So, to summarize, for any rational numbers a, b, c, a plus b in brackets plus c is equal to a plus in brackets b plus c. Are subtractions for rational numbers also associative? Let's find out. Suppose Aditi has 4/5 chocolates. Out of that, she gives 2/5 part to Ankit and 3/10 to Suman. So tell me, how much chocolate will be left with Aditi? We can represent the given situation in this way. Let's solve this by forming different groups. If we make a group of 4/5 and 2/5, then we will get 2/5 as a result of 4/5 minus 2/5. If 3/10 is subtracted from it, the result will be 1/10. Now, pause the video and find out if it is solved by forming a group of 2/5 and 3/10, what will be the result? Let me tell you, we can simplify it in this way. We will get the result 7/10. Here, the results are not the same in both cases. Therefore, any three rational numbers a, b, and c cannot be grouped in any way. It is necessary to subtract them in the given order. We can say that subtractions for rational numbers are not associative. Means, here the result of the first case is correct and the result of the second case is wrong. So, we can say that Aditi has 1/10 chocolate left. Now, pause the video and multiply any three rational numbers by grouping them in different ways. Are the results equal? So, are multiplications associative for rational numbers? Absolutely right. Rational numbers A, B, C can be multiplied by grouping in any way. The result will always be equal. Therefore, we can say that multiplications for rational numbers are associative. Here, the results in both cases are equal. Similarly, let us find out whether division is associative for rational numbers. If we simplify 6 by 7 divided by 4 by 3 divided by 1 by 12, in this way, the result will be 54 by 7. But if we simplify it in this way, we will get the result 3 by 56. In both the cases, here the result is not equal. So, the rational numbers A, B, C cannot be divided by grouping in any way. It is necessary to do this in the given order only. Therefore, we can say that for rational numbers, division is not associative. In this way, here, the result of first case is true and the result of second case is false. Now, you must have understood that the addition and multiplication for rational numbers is associative, but subtraction and division are not associative. Today we see of different operations on rational numbers. Manish cut a rope into 4 pieces. The length of pieces was as follows. Can you tell what is the total length of the rope? The length of 4 pieces of rope is 7 by 9 meter, 5 by 12 meter, 11 by 12 meter and 5 by 3 meter. Therefore, the total length of the rope will be the sum of these 4 pieces. Total length of rope is equal to 7 by 9 meter plus 5 by 12 meter plus 11 by 12 meter plus 5 by 3 meter. Here we see that denominators of 5 by 12 and 11 by 12 are equal. So it is easy to add them. Since the addition is associative for rational numbers, we can simplify this bracket first by taking 5 by 12 and 11 by 12 in parenthesis. This will give us result of the brackets 16 by 12, which we can write 4 by 3. Now we will take parenthesis on 4 by 3 and 5 by 3. Solving 4 by 3 plus 5 by 3 will result in 9 by 3, that is 3. Now 3 plus 7 by 9 is equal to 3 and 7 by 9, that is 34 by 9. Therefore we can say that total length of the rope is 3 and 7 by 9 meters. Next example. Rahul gave 2 by 3 portions of his 1 and 4 by 7 chocolate to Amit. Amit gave 3 by 4 of the chocolate he had to Neeta. Find how much chocolate Neeta received. Rahul has 1 and 4 by 7 chocolate, that is 11 by 7 chocolate. Amit is getting 2 by 3rd part of this chocolate, that is Amit is getting 2 by 3 multiplied by 11 by 7 chocolate. Neeta is getting 3 by 4 part of it. So chocolate obtained by Neeta is 3 by 4 multiplied by 2 by 3 multiplied by 11 by 7. Let's solve it. Multiplication for rational numbers are associative. So we can group here as follows. By simplifying the parenthesis, we get the rational number 1 by 2. Now we multiply 1 by 2 and 11 by 7. This will give us the result 11 by 14. In this way, Neeta gets 11 by 14 of the total chocolate. Next example. Sunita and Manisha were solving 68 divided by 17 by 25 divided by 17 by 25. Both of them simplified it as shown. But the results of both came differently. Can you tell whose answer is correct? And why? Divisions for rational numbers are not associative. That is, groups cannot be created in any way in operation of a division. Here, Manisha has formed the wrong type of group, due to which she has got the wrong answer. Rational numbers must be divided in given order only. Sunita must be knowing this. So, she has got the correct answer. So, today we have seen examples related to associative property.
In today's video, we will learn about the closure property of rational numbers. Children, you must have read about numbers in previous classes. Now let us revise this once. Children, what are natural numbers?
Sir, the numbers which we can count are called natural numbers. Like we have 1, 2, 3, 4 and 5 fingers in one hand.
Well done, Rahul. Children, now let us move ahead and add 0 to these natural numbers. Now, who will tell what we call such a group of numbers?
Sir, we call this group of numbers whole numbers.
Mohan, you are right. Children, you may all know that sometimes we have to use negative numbers. Like during winter, the temperature drops to 0 in many places. This is represented by a negative number, like -2 degrees Celsius. Now if we add negative numbers to whole numbers, then what is the group of numbers called?
Sir, we call this group of numbers integers.
Well done, Rahul. You remember everything from the previous class. Children, you have learned about fractions, where we used to write a number as a numerator and denominator. Now look at this number line. If we go half a step right from 0, we get 1/2. But when we go to the left from 0, we get negative numbers. For example, going half a step left, we will get -1/2. You can see here that it is neither an integer nor a fraction, because the numerator and denominator must be positive to be a fraction. So what is this number?
Sir, this is a rational number.
Well done, Mohan. Children, now can you tell the definition of rational numbers?
Sir, rational numbers are numbers that can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. Sir, why can't Q be equal to 0?
Mohan, if I ask you the value of 8/2, what will you do?
Sir, I will search for a number which when multiplied by 2 gives me 8, and that number is 4.
Well done, Mohan. Now, what is the value of 8/0?
Sir, this cannot be found. I can't find any number which gives me 8 when multiplied by 0.
Rightly said, Mohan. And we call such a number undefined.
Sir, I have understood now.
Children, you have already learned about closure property in the previous class. Can you tell me, what is closure property?
Whenever we use an operation on the numbers of a set and the resulting answer also falls within the same set, then we consider that set to be closed for that operation.
Well done, Rahul. Children, now add these integers and see, will we get an integer after adding them? You can pause the video and try. Children, what can we say about the closure property of integers?
Sir, integers are closed under addition because every time we add two integers, we will get another integer.
Well done, Mohan. Are rational numbers closed under addition? Let's examine it. We take two rational numbers. What will we get by adding 1 by 4 and 2 by 3? You too try to solve this question. Children, is this also a rational number?
Yes, sir, it is a rational number.
Children, now add the following rational numbers and observe the result. Children, you will see that adding any two rational numbers gives another rational number because rational numbers are closed under addition. Children, in this session, we learned about different types of numbers such as natural numbers, whole numbers, integers, and rational numbers. We also verified the closure property under addition of rational numbers. Hello friends, welcome to this video. We have previously learned that rational numbers are closed under addition. Are they also closed under subtraction and multiplication? Let's see. Children, we have discussed the closure property of rational numbers under addition. Now let us discuss it with respect to subtraction. Children, subtract 8 from 3.
Sir, the answer is -5.
Well done, Rahul. Children, now look at this table. Here 3 and 8 are natural numbers. But the answer obtained by their subtraction is not a natural number. Children, by looking at this table, you can say that subtracting two natural numbers does not necessarily give a natural number. Sir, it means that natural numbers are not closed under subtraction. Yes, Mohan. Can you find out the same about whole numbers and integers using this method?
Yes, sir. Even whole numbers are not closed under subtraction.
Well done, Mohan. You have answered it correctly. Children, you may also remember what you had studied in the last class about integers. Integers are closed under subtraction.
Sir, do rational numbers have the same property as integers?
Let's see. Let us now take two rational numbers such as 5 by 2 and 2 by 5. Subtract them and tell me the answer.
Sir, the answer is 21 by 10. And this is also a rational number.
Children, let's take another example. Let's find 4 minus 2 by 3. You too should solve this question. Children, did you also get 10 by 3, which is a rational number? Children, now look at these numbers. Did you get rational numbers as the result? You too should solve this question. Children, you must have obtained a rational number by subtracting these numbers. Because rational numbers are closed under subtraction. You can also do this for other rational numbers. Now children, we shall discuss about closure property under multiplication. We will take two rational numbers. What will you get if you multiply 2 by 7 and 3 by 5?
Sir, we will get 6 by 35. And this is also a rational number.
Children, will you get a rational number if you multiply -1 by 3 and 2 by 5?
Yes, sir. This time too we have got a rational number.
Children, multiply these numbers now. You too should solve this question. Children, this time too you will get a rational number after multiplying these numbers. This is because rational numbers are closed under addition and subtraction as well as multiplication. Children, so far we have discussed the closure property of rational numbers under subtraction. Children, here we can see that Rahul covered equal distance in both the situations. While adding these numbers here, we see that changing their order did not change the answer.
Sir, two integers are being added here.
That is why in every case the sum of the equations is the same.
Because the addition of integers
Is commutative.
Rightly said, Sohan. Now explain to everyone the meaning of commutative property.
Sir, commutative means that even after changing the order of numbers in an operation, the result doesn't change. That is, the change of order doesn't affect the result.
As we have seen here, if we add these two integers in any order, their sum does not change.
If we add or multiply any two integers such as a and b in any order,
There is no change in the answer.
because the addition and multiplication of integers are commutative.
You are right, Sohan. Sohan, in the last class, we learned about the commutative property of natural numbers, whole numbers, and integers. Now let's discuss the commutative property of rational numbers. Rational numbers are numbers that can be written in the form of P by Q, where P and Q are integers and Q is non-zero number, such as 4 by 7, minus 10 by 49, etc. We can also write natural numbers, whole numbers, and integers as P by Q. Here, we can write 1 as the denominator.
So these are also rational numbers.
Let us now discuss the commutative property.
Of addition of rational numbers.
Suppose we have two rational numbers.
Now let's add them in this order.
How do we add such numbers? Like we used to add fractions, with the help of the least common multiple, LCM. Here the least common multiple of the denominator is 12. Adding these, we will get the answer 11 by 12. Now let's change their order and again add them. We will see that the answer will still be 11 by 12. Children, now you add the numbers given on the screen in this order. Keep in mind that the number 5 that is in the first question here can also be written as 5 by 1. Pause the video and solve these questions and write the answers. These are the results. Now change the order of these numbers and add them again.
Sir, even after changing the order, our answers are the same.
Children, you can all see that changing the order of addition of rational numbers did not affect our answer.
Because the addition of rational numbers is commutative.
That is why we can add any two rational numbers like A and B in any order. Children, but is the subtraction of rational numbers also commutative? First, let's take two rational numbers, such as 3 by 4 and minus 5 by 6. Now first subtract minus 5 by 6 from 3 by 4, which we will do in this way. Next, change the order of the numbers and subtract 3 by 4 from minus 5 by 6 and state the answer.
Sir, we have got a different answer in both the cases.
You are right, Mohan. solve all the questions given here. Please pause the video and solve these questions and write your answers. Now change the order of numbers in each question and solve them again.
In each of the given questions, our answer changes whenever we change the order of numbers.
We can see here that changing the order of numbers in subtraction changes our answer, because subtraction of rational numbers is not commutative. That is why we can say that
For any two rational numbers, a and b, a minus b is not equal to b minus a.
let's go ahead and discuss the next operation, multiplication. Is multiplication of rational numbers also commutative? Let's see. For this, we take two rational numbers. Multiply both these numbers.
The answer is 35 by 12.
Now let's change the order of these numbers.
Sir, our answer is still 35 by 12.
Now all of you solve these questions. On solving these questions, you must have got these answers. Now change the order of these numbers and multiply.
Sir, swapping the numbers did not change our answer.
You are right, Mohan. This is because the multiplication of rational numbers is commutative.
We can say that
A multiplied by B is equal to B multiplied by A for any two rational numbers A and B. Children, now let's check the commutative property of rational numbers in division. Now look at the two rational numbers given here and divide them in this order, keeping in mind that 2 to the power of 2 is 4. Now change the order of these numbers and then divide them. What did you understand from this?
Sir, here the answer in both situations is the same.
Children, considering this one example, can we say that the division of rational numbers is commutative? Let's see some more examples. Children, now look at these rational numbers and divide them in the same order. Write the answers in your notebook. Now change the order of these numbers and divide them again. Now compare the answer with the answers that you have written in your notebook.
Sir, on changing the order of this question, our answers are different. When we divide 0 by 5, the answer is 0. But dividing 5 by 0 gives the answer 5 by 0.
By dividing 5 by 0, we get an undefined answer. Here, with the help of examples, we have learned that